Today we're going to take a look at using permutations and combinations to actually calculate probabilities. So far we've just been counting possibilities. Now we're going to actually find favorable outcomes divided by all possibles to get probabilities. So here's an example. Lulu has a collection of 26 mounted insects. 16 are butterflies, 10 are moths. She randomly chooses 8 insects to take the science fair. What's the probability she chooses 4 butterflies and 4 moths? Okay, so the first thing we do is look at the 8 insect selections, and we got to figure out what are the conditions that we want to meet, meaning we want 4 from the butterfly group and 4 from the moth group. And then once we get those possibilities, we'll use the counting principle to find the total number of favorable selections. Then we got to figure out what are all the possible combinations of 8 insects you could draw from a group total of 26. And then once we do that, we have the favorable divided by all possible, we can get our probability. So let's try it. So here we are again, I've rewritten the problem, 16 butterflies, 4 moths. So we got 8 insects to take to the fair. Okay, so that means our total possible, let's do that part first, our total possible outcomes, we want 8 taken from the entire group of 26. Okay, so 8 taken from 26. Notice I chose a combination because there's nothing in here about order. They have come in a specific order. Just we're going to take 26 different insects, we're going to choose 8. That's all the possible outcomes. Alright, so I kind of did the last part first, but let's move on. So the favorable outcomes, we want to figure out of the 8 that we choose, how can we get them to be 4 butterfly and 4 moths? Okay, so our 4 butterfly, again, it's a combination because we don't care about the order, we're just trying to get a group of 4 butterflies. We're going to choose 4 from a total of 16 butterflies. There's 16 butterflies to choose from, we're going to choose 4 of them. Moths, we want to get a total of 4 of those, and we're going to choose them from how many? 10. So we get 10 moths, choose 4. Now, to find all of our favorable outcomes, we want 4 butterflies and 4 moths, so we're going to use the fundamental counting principle and multiply those. So we'd say the probability of 4 butterflies and 4 moths is 16 choose 4 times 10 choose 4, that's the butterflies and the moths, divided by the total possible. If I work that out in my calculator, I got 0.24. Hopefully you get the same thing. Okay, so we're going to play Scrabble now. We've got Scrabble, there are 56 consonants and 42 vowels. So we want to choose 7 tiles. What's the probability of choosing 4 consonants and 3 vowels? Okay, so in probability lingo, the P, parentheses, 4 consonant and 3 vowels. Alright, so let's start by thinking about all of the possible 7 tile draws you could take. So you're going to start with 56 plus 42, which is 98 possible tiles, and you're going to choose 7. So what are all the possible combinations of tiles? It's going to be 98, choose 7. Big number. Now we want to figure out if I want to get 4 consonants. Okay, so 4 consonants, I've got 56 consonants to choose from. So I'm going to go 56, choose 4, because I want 4 consonants. And then my vowels, I've got 42 vowels to choose from, so I'm going to take 42, choose 3. And I want 4 consonants and 3 vowels, so fundamental counting principle will multiply those together. So the probability of 4 consonants and 3 vowels is 56 choose 4 times 42 choose 3 all over 98 choose 7. When I work that out, I get 0.30 as the probability. So the probability you get 4 constant 3 vowels is 0.30. Next problem. Lulu signed up for classes. You got English pre-calc, Spanish geography, chemistry. Sounds similar to a problem we've done before. Okay, if class schedules are assigned randomly and each class is equally likely to occur at any time of day, what's the probability that Lulu's first 2 classes will be pre-calc and chemistry in either order? Okay, so we're doing a probability problem now. I think before we just did some counting, but now we're actually going to calculate probabilities here. So how many 2-class arrangements meet these conditions? That's the first thing you need to do. And then use a fundamental counting principle to find the number of favorable selections. So we'll start with the arranging the pre-calc and chemistry, and then we'll figure out the rest. And then finally, we've got to figure out all possible combinations to get the probability. Now in this case, order is going to matter, so I think we're going to be using permutations here. So let's take a look. So our first two classes are kind of preset. They're going to be pre-calc and chemistry, or chemistry and then pre-calc. So if you want to do that in permutation form, you say that's 2 choose 2 from a permutation perspective. And there's really only two ways you can do those first two classes. So we'll start with the 2. So the first two classes could start with either one or the other, but there's two possibilities. Now, for the next 4 classes, we've got 4 classes to choose from, and all of them are going to be favorable, given that we've got our first 2 set. So probably a 4 choose 4 is just 4 factorial. There are 24 possible choices. So next, and the last thing we want to do is find all of the possible schedules that we might get, given that there are 6 classes, which is the permutation of 6 choose 6, which is 6 factorial. So using the fundamental counting principle, we've got 2 possibilities for the first 2 classes and then 24 for the next 4. So we multiply those out to get all of the possible combinations and divide by 720, which are our possible schedules, to get 0.067. So that's our probability of getting the first 2 classes being chemistry and pre-calc. All right, now this is an interesting problem. It says there's 5 comedians to put on a show: Al, Bob, Carl, Dan, and Eric, A, B, C, D, and E. Their order of appearance is totally random. What would be the following probabilities? Okay, so the first one is the probability that Bob goes second. Okay, so we need to figure out all the favorable outcomes that include Bob going second. This is a permutation, but you could also just do it by using a little structure system. Remember, structure systems are basically permutation problems. So I'm going to set Bob up in the second slot, and then I'm going to think about, okay, then how many different people could be in the first slot, and the third slot, the fourth slot, the fifth slot. So given that Bob is in the second slot for sure, since that's a probability of Bob going second, I have 4 possibilities in the first slot, because there's 4 guys left, 3 in the second, 2 in the third, and 1 in the last. Okay, so I'm going to go ahead and set up the favorable outcomes for the next one, and then we'll do the probabilities here. So in the second one, we have the probability of Bob being second and Al being last. So we're going to nail those down. We have Al in the last slot, Bob in the second. So how many different combinations could we get now? Well, we have 3 slots left for the first slot, 2 for the third, 1 for the fourth. Okay, so we get 6 possibilities. Okay, now let's calculate the probabilities. We need to know how many possible orderings could we get, given that we have 5 comedians. So this is going to be all possible. So we'll find the permutation probability of Bob being second is going to be 24 divided by the permutation. Remember, this is different orders. What are all the different orders of these guys appearing, which is the permutation of 5 chosen 5 at a time, which is just 5 factorial. And so we get 0.20. And then the next one is the probability of Bob going second and Al going fifth. Favorable outcomes are 6 of them, and then total possible are, again, 5 permutation choose 5, which is 5 factorial, and so again we get 0.05. And that concludes our lesson for today.